Okay, everybody, we're here to discuss lesson 11-6, where we are going to learn to add and subtract rational expressions. One of the ways that I've defined rational expressions to you is anything that can be expressed completely as a fraction. So what we're going to do today is going to remind us a little bit about how we actually deal with fractions. For example, you know what to do if you have 1 over 6 plus, oh, I don't know, let's say 5 over 6. How do I do that math? Well, I just add my fractions together. And the way I have to do that is to make sure I have a common denominator. If I have a common denominator, all I have to do is add the numerators together. In this case, I'll get 6 over 6, and then simplify if I can. 6 over 6 is just 1. Let's try another example. Let's say 1/3 plus 1/3. Again, if we have a common denominator, all we have to do is add the numerators together and we get our fraction. If we can simplify, we should. In this case, we can't. That's as simple as that one gets. When we don't have a common denominator, let's say I have 1/4 plus 1/2. The first thing I need to do is to make sure I get a common denominator. And in this case, what would be the lowest common denominator I could use? I think the lowest common denominator I would use in this case would be 4, because 4 is the smallest number that both 2 and 4 go into. So I'm going to change this one to something over 4. In order to get to a 4 from 2, I have to multiply by 2, so I also have to do that to the top. And 1/2 becomes 2/4. Okay. Then in order to add these, I'm going to just add the numerators and leave the denominator the same. And that's how we add fractions. We can do the same sort of thing with subtracting, but that's the big idea of what we're doing with fractions. Okay. When we have a rational expression, maybe we have something like this. We have 5n over n plus 3, and we want to add 15 over n plus 3. Well, when we have a common denominator, this isn't too difficult. All we need to do is add the numerators. So that's going to be 5n plus 15, all divided by n plus 3. Remember, when we're adding fractions, we leave that common denominator as part of the answer. We don't multiply them together or do anything else crazy. We just leave the denominator, but we add the numerators. Now we have to look and see if there's anything that we can do to simplify. When I look at this top thing, I see, well, I've got something that looks common. What is common to both of these terms in the numerator? Okay, is there a 5 in both of them? So when I factor out a 5 here, when I factor out a 5 from the first term, I'm left with n. When I factor out a 5 from the second term, I'm left with a 3. So 5n plus 3, or 5 times n plus 3. If I distribute that through again, I'll get 5n plus 15, which is what I had there. And then I'm going to divide it by n plus 3, because that was what the denominator is. Now we can see that we have an n plus 3 in the top and in the bottom. So our final answer is just going to be 5. That's not so bad. I want you to stop the video and try 1b on the bottom of page 706. 1b, you're going to do 4t over 5xy plus 7 over 5xy. Stop the video and try it on your own. Okay, you're back because you've done it on your own and you want to see if you got it right. We already have a common denominator, so that's just going to stay the same. And in the top, I have a 4t here and a plus 7. Okay. Does anything at all simplify for this one, or is it already prime? Well, I have a plus sign, but I don't have anything common in the top. And in the bottom, I don't have anything to factor. That's already, as factored out as that can possibly be. And nothing simplifies top to bottom. So in this case, it's prime. That's as low as you can go. You just had to add the numerators and nothing simplified. Subtracting rational expressions is really much the same as you would expect. 3m minus 5 over m plus 4 minus 4m plus 2 over m plus 4. Okay, this is our sample problem. We're going to learn with this one. When we have a problem like this, and we've got our minus sign here, the only tricky thing with this minus sign, the only tricky thing with subtraction, is that when that minus is written in the middle, that means it has to apply to this entire numerator. So we have to be sure to use the distributive property here. But we already have the same denominator, so I'm going to just write that down, m plus 4. I've got 3m minus 5 there. Let's make this fraction bar a little longer. And then I'm going to say minus 4m here, minus 4m. And the tricky part, it's also a minus 2, right? We'd have to change this sign. So it's going to be a minus 2. And then we get negative m minus 7 divided by m plus 4, right? And that would be as simplified as this one gets. Sometimes people would prefer to factor out a negative 1 because they like to keep positive numbers. So sometimes people would write it as negative. If I factor out that negative 1 here, I'm going to be left with m plus 7, because if I divide this by a negative, I get a positive m. If I divide this by a negative, I get a positive 7. So that negative is out front, divided by m plus 4. And nothing there will factor, so either one of these two answers would be considered correct or simplified. All right? I want you to stop the book, or stop the video, and try number 2A on the page 707. 2A. 2A looks like 2h plus 4 divided by h plus 1 minus 5 plus h over h plus 1. Okay, that is our problem. Now I know you stopped it and have tried it already on your own. You already have a common denominator. So all we have to do is add our numerators together. So it's 2h plus 4 minus 5, and then what? Minus 5, and a positive h is a minus h, all divided by h plus 1. So 2h minus h is h. Okay, right? 2h here minus h here is a positive h. And 4 minus 5 is a minus 1. That's our numerator. In the denominator, we have an h plus 1. And that does not simplify anymore. That would be lowest terms for this problem. If you have a question about this, if you don't understand something I did, bring it to class and we'll solve that problem. All right. The next example I have for you is 3n over n minus 4 plus 6n over 4 minus n. Now you might say, well, we don't have a common denominator, so we can't do anything. Well, that's not true. If you look at this carefully, we've got a positive n and a negative n, and a negative 4 and a positive 4. So in order to make these the same, all I have to do is somehow change the sign on everything. And the way I can do that, I'm going to do this in the second one, is I can factor out a negative 1. So if I make this a minus 6n, this minus could go to the numerator, or it could go to the bottom. It could go to so if I'm factoring out a negative 1 from here, I'm going to end up with a negative 4 plus n. Okay? Remember, all I'm doing is factoring out a negative 1 from the denominator, and I'm sticking it right in the middle. It doesn't matter if this sign goes to the numerator or the denominator, as long as it comes from one of them. But now this, I'm just going to change the order that I'm writing them in. I have 3n over n minus 4 here, minus 6n over, I'm going to write the n first, it's a positive n, minus 4. Now I have a common denominator. This is a little tricky, but be sure you understand it because this sort of thing comes up a lot. We've got to understand where those signs are coming from. Now that I have a common denominator, I can simply add the numerators together. So I have 3n minus 6n, that's a negative 3n over n minus 4. Ta-da! That is our final answer. Okay? Any other questions that we can talk about in class? But this is the biggest chunk of what your homework is going to be for everything where you have a common denominator. We are going to have some things where we don't have a common denominator. I'm going to do just one sample problem tonight, and we'll talk about these in class because I know this is going to come up. So when you do not have a common denominator, you have something like 3t plus 2 divided by t squared minus 2t minus 3 plus t plus 1 divided by t minus 3. Okay, well, we don't have a common denominator here, do we? Well, let's see what we can factor. Is there anything common that factors in the numerator here? How about here on the bottom? Well, if this was going to factor, I would need something that would multiply by a negative 3 and add to a negative 2. I'm going to make my little t. Multiply to a negative 3. That would be something like negative 1 times 3. And when I add those together, I get a 2. That's not what I like. I don't want a 2. I want a negative 2. Well, let's try it the other way. Let's try a negative 3 times a positive 1. Because that multiplies to a negative 3. And when I add, that becomes a negative 2. And yay, that is exactly what I need. So this will factor. In the numerator, I have a 3t plus 2 divided by t minus 3 and t plus 1 plus t plus 1 on top here and t minus 3 here. You see how you have a t minus 3 here and here? That's kind of like adding 3 over 6 plus 1 over 3. I could factor that 6. 3 over 2 times 3, that's the same thing, right? Plus 1 over 3. So I've got the 3's on both of them. That means I'm going to multiply this 2 times the top and the bottom, so that I can get a common denominator here. You can finish this on your own, but this is the same idea that I'm going to do right here. Here I've got the t minus 3 on the bottom, and I've got a t minus 3 on the bottom. In order to get a common denominator for here, I need to multiply this one by a t plus 1. So if I multiply t plus 1 here, t plus 1, now on the denominator I have the same denominator for both of these two fractions. But the problem is if I multiply the denominator of one side by the bottom by a t plus 1, in order to keep it from changing and keep it the same number, I've also got to multiply the top of that fraction by a t plus 1. Because this is the same thing as multiplying this whole fraction by 1. And if I multiply by 1, I'm not changing anything. Kind of a weird thing. But now I have a common denominator. Okay, so 3t plus 2 plus, if I FOIL this out, I'm going to get t squared plus 2t plus 1 divided by t minus 3 times t plus 1. Right? Let's simplify everything we can. I've got a t squared. I can't add anything to that. I've got 2t plus 3t is a 5t. And now I have a 2 plus a 1. That's a 3 divided by t minus 3 times t plus 1. It's worth checking at this point to see whether or not this top thing will factor. If the numerator factors, it could be that one of those factors will cancel with something on the bottom. In this case, this numerator does not factor. So our final answer is going to be just that. It's given there. By the way, when you look at that answer, do you see any excluded values? Excluded values for this expression are going to be when t is equal to 3 or t is equal to negative 1. So t cannot be 3 or negative 1 because that would give us an undefined solution. Think about these, work on these, and let's see how far we can get for the next time in class, and if we can answer any questions you have about these in class, that would be a good time to do so. Okay? Enjoy your homework. See you in class.